right, so here is where we left off from the last video. So we have two postulates. We have parallel postulate. So what this is saying is that if you have one point that is not on the given line, right? So point P is not on the given line L. There's only one line that can pass through P and be parallel to L. Now, make sure you understand the notation. These arrows, okay, on the line, that indicates that those two lines are parallel. Just like the congruent notches, that means the line segments are congruent. The arcs on the angles, that means that those angles are congruent. The arrows, that is making you aware that those two lines are parallel. Perpendicular postulate, kind of the same scenario. You have line L, you're given line point P. There's only one line that can pass through P and be perpendicular to line L. That's what that is saying. All right, kind of mentioned this when we were reviewing for the chapter 2 exam on Monday. I reviewed, as I was reviewing, I said, you know, we're going to talk about this again in chapter 3, and this is what I was talking about. Perpendicular transversal theorem. Okay, you are told that you have two parallel lines. Okay, so if this line, okay, this transversal that passes through this first line is perpendicular, okay, then it is also perpendicular to the parallel line. And so this statement is perpendicular to the other.
Teachers, staff, and students.
Okay.
It is quite really outside, and so.
All right. So, here, if alternate exterior angles are congruent, then you know you have parallel lines. If alternate interior angles are congruent, then you have parallel lines. If corresponding angles are congruent, then you have parallel lines. Now, so the first three are all congruent. This new set of angles that we talked about is same side angle, interior angles, or if they're referred to as consecutive, interior angles. If they are supplementary, then your lines are parallel. Okay, so these are the four terms that are new to us in our terminology besides vertical and linear pair. So these are our new ones, all right? So we need to pay attention to this. Same side supplementary, all right? So if you have same side supplementary, you have parallel lines. All other types of angles are going to be congruent, of course, with the exception vertical and linear pair. But we already talked about that. Vertical angles are always going to be congruent. Linear pair will always be supplementary. So focusing on our new terminology, same side supplementary, all other types of angles are going to be congruent. Okay, so here you have to determine which sets of lines are parallel given this information. So if angle 1 is congruent to angle 9. Now, in the back of your mind right now, I know you're watching this video at home, okay? So I'm going to kind of stay out of it, okay? I'm going to stay out of this window. You may see me point, but that's it. I want you to think, what's the relationship? Alternate interior, alternate exterior, corresponding. 1 and 9. Okay, they're corresponding. So, since they're corresponding, which transversal does it have nothing to do with? Okay, R1 or 9 formed by line D at all? No. So, since it has nothing to do with line D, A has to be parallel to B. All right. Then you have 7 and 3. Okay, so 7 congruent to 3. Now I want you to think about it. Pay attention to what line does it have nothing to do with? Has nothing to do with B. So do we have alternate interior, alternate exterior, or corresponding? Since they're congruent, alternate interior. So therefore it had nothing to do with B. So then it is the two lines that are parallel is C parallel to D. Now here I have supplementary angles. Okay, now you have to pay attention. So 7 and 2 are supplementary, but why? They are a linear pair. Okay, linear pair is always going to be supplementary. Now think about it. 2 and 7, the only two lines that have any relation with those two angles is line A and line C. Okay? It has nothing to do with B and nothing to do with D. Because it's a linear pair, you cannot prove that you have parallel lines. Linear pair will always be supplementary. All right, 3 and 13. 3 congruent to 13. Which line does it have nothing to do with? Has nothing to do with line C. So here, as some students like to call it, it makes the Z, but it's outside the Z. They're on alternating sides of the transversal, and inside, outside the two lines that are parallel. So that's alternate exterior. And you might be saying, but Ms. Colley, 3 is inside. But is 3 inside the two lines that are parallel? Okay. Is 3 inside the two lines that are parallel? No, it is not. So therefore, that is why it's alternate exterior, and that is A parallel to B. Okay. 16 and 4. All right. 16 and 4 are way too far apart from each other. Okay, they are way too far apart from each other. So, and if you think about it, 16 is formed with line C and line B. 4 is formed with D and A. There is no common transversal. There is no common line. Whereas if you go back, all the others have a common line, which is called the transversal. So since they're too far apart, there is no common relation. That's going to be none. All right. 2 and 3 are supplementary. So you want to check, is it same side supplementary? 2 and 3, yes, that is same side interior. So therefore, the two lines have nothing to do with B. So then C parallel to D. All right, 5 and 11. Again, that would be alternate interior angles. And it has nothing to do with C, so A parallel to B. All right, 10 and 12. 10 and 12 has nothing to do with line A, and that would be corresponding. If I cut these 4, place it on top of here, 10 would sit on top of 12. So C parallel to D. Okay, 4 and 6. 4 and 6 are vertical angles. And so vertical angles are always going to be congruent. And so we don't necessarily have parallel lines. That would be none. Okay. And lastly, I have 8 and 6. So 8 and 6. 8 and 6. Again, that would be corresponding. It has nothing to do with line B. So C is parallel to D.